All right, ladies and gentlemen, we are going to talk about intramolecular and intermolecular. The first thing with intramolecular, we're talking about bonds that occur within a molecule. And what that means is if we have water, okay, we're talking about what's going on between the oxygen and the hydrogen. However, intermolecular are attractions between molecules. So there needs to be more than one. And if we were to talk about water, we would talk about it like this, and there would be another water molecule. I'm going to draw it kind of up like this, and the attraction comes between the positive and negative. This is the negative side, this is the positive. This right here is that interaction. The more of those interactions we have, the more water molecules can stick together. And if they are sticking together, then you have water either as a liquid or a solid. Okay? So intermolecular helps us to determine the state of matter. Okay? Now, your job is to know what the three are and the three differences, and then be able to identify them. So the three different intermolecular forces we're going to deal with are London dispersion. Then we're going to have dipole-dipole. And then we're going to have a special type of dipole-dipole called hydrogen bonding. Okay? Now, everything has London dispersion. Everything, okay? But there's certain ones that are only London dispersion. And all London dispersion is when a temporary, and we'll also use the word momentary, and we'll also use the word instantaneous. They all mean the same thing. Dipole is formed when all the electrons go to one side. That's really all it is. They kind of just all go to one side. And when that happens, you end up with a temporary positive and a temporary negative. These are temporary. And when that happens, molecules can attract. I can't spell molecules. Now, these forces are weak forces. Okay, it's very important you understand that these are the weakest, London dispersion. Now, dipole-dipole, they're the medium forces. And all the dipole-dipole is, all that is that one side of the molecule is positive, naturally, and the other is negative. This happens in polar molecules. This happens in polar. This is polar, okay? And they're medium forces. And then hydrogen bonding is strong forces. And all it is dipole-dipole, except for it's a positive hydrogen's positive, that would react with or attract to F, O, or N. Okay, and that's what you have to know. And each of these are fairly negative, okay? So that's a special type of attraction. Not a bond, just attraction. So let's talk about what you have to do in order to do this. So remember we had a flow chart, and we didn't get to the bottom. Here's your intermolecular part of this flow chart. First thing you ask is it polar? If it is, then you have to ask, is hydrogen with F, O, or N? Or as I call it, fon. If the answer is no, you have dipole-dipole. If the answer is yes, you have hydrogen bonding. However, if you go back up here to polar, if it's not polar, it's London dispersion forces. A long time ago, I had a student who said, non-polar, London's in the north. That helped him remember, and if that works for you, that's great. So let's do some examples. Let's go back to the problems from the previous video. Okay, this was draw the Lewis structures, okay, and then figure out if something is polar or non-polar. So the first thing you always end up having to do is draw the Lewis structure. The second thing is polar or non-polar. Once you know that, you can figure out the IMFs. So first off, water, it's polar. So I'm going to look at my flow chart here, and I have this nice flow chart. It's polar, yes. Is hydrogen going to end up being able to react with F, O, or N? So there's an O there, so this is called hydrogen bonding. That's it. Let's take a look at the next one. The next one is oxygen, and here we have it. We've decided it's nonpolar, so if it says polar, the answer is no. Oh, all we have to do is write LDF, London Dispersion Forces. Done. All right, our next one is CH4. Okay, is that polar? Nope, so that's London Dispersion Forces. Easy breezy. All you gotta follow is this right here. Our next one, CH3I, when you look at it, that's polar. However, is hydrogen able to ever mess with F, O, or N in this problem? The answer is no, so this would be dipole, dipole. Hopefully this clears up how you would go about identifying intermolecular forces. Bye!